In this video, we're going to talk about finding rational and real zeros using the rational root theorem and the fundamental theorem of algebra. The rational root theorem states, for a polynomial f of x equals an x to the n, an1 minus 1 to the x to the n minus 1, etc., a1 to the x plus a0, or an minus 1 all the way to a0 integers, the rational roots can be determined from the factors of an and a0. More specifically, if p is a factor of a0 and q is a factor of an, then all the rational factors will have the form plus and minus p over q. In other words, the factors of the constant divided by the factor leading coefficient will yield all the possible rational solutions of f of x. The fundamental theorem of algebra states any polynomial with complex coefficients of degree n has at most n complex roots, including repeated roots. Example 1. Determine the possible number of roots. Determine what the possible roots are and what the largest is, and determine what the roots are. So for determine the possible number of roots, we find the largest exponent. In this case it's 4. So by the fundamental theorem of algebra, so let me say by FTA, there are at most 4 roots. These could be real roots or complex roots. Okay, determine what the possible roots are and what the largest is. So then now we're going to use the rational roots theorem. So we'll say by rational roots theorem. So we have p and q. If we recall, p is a factor of a0 and q is a factor of an. So p, we're talking about factors. So let's just simplify this just a little bit. Our a0 equals negative 10. So that means our factors of a0 are p. So we have factors of 10. It's going to be plus and minus 1. Plus and minus 2, plus and minus 5, and plus and minus 10. All these numbers multiply to 10. 1 times 10 is 10, and 2 times 5 is 10. Now our an is going to be 6. That's the leading term. So our factors of 6 are going to be plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. Now it's asking what is the largest. So remember, they're always going to be in the form of p over q. Our largest number is 10. Our smallest is 1. So our largest is just simply going to be 10 divided by 1, which is going to be 10. So this is our largest possible root. And we're done. Now determine what the roots are. For this, we're going to use Desmos because it's a long drawn out process. So in Desmos, we're going to type in our polynomial. So it'll be 6x up to the 4th. And we'll just shrink this down. Oops. Minus 43x to the 3rd. plus 66x squared minus 3x, and then our last one is going to be minus 10. So we can quickly find our zeros using Desmos. Our first real root would be negative 1/3 comma 0. The next one would be negative 1/2. Next one would be 2, 0, and our last one would be 5, 0. So our roots are negative 1/3, and if we look at our P's and Q's, this would be my P, this would be my Q, and we do see 1/3. Our next one would be 1/2. And if we look at our list, 1 and 2, that falls in the form of P over Q. We can pull the 1 from the P, the 2 from the Q. We also have 2 and 0 and 5 and 0. So we have 2, which can be written as 2 over 1, which is actually can be written as form as P over Q. So we can pick the 2 from the P list, the 1 from the Q list, and we're done. And then our last one we can write as 5 or 5 over 1. We pick the 5 from our P list and the 1 from our Q list, and those are all the zeros, our roots of our polynomial 6x to the 4th minus 43x to the 3rd plus 66x squared minus 3x minus 10. And we are done. Example 2. Determine the possible number of roots. Determine what the possible roots are, what the largest is, and determine what the roots are. So we have a volume of 24, and the sides are 3x minus 1, 2x, and x minus 4. So first we have to find the actual volume. So first we have to multiply. So let's quickly make a box and multiply out our polynomial at 3x minus 1 and x minus 4. So 3x times x will be 3x to the second power. 3x times negative 4 is going to give me negative 12x. Negative 1 times x is going to give me negative x. And negative 1 times negative 4 is going to be a positive 4. Like in the previous video, we're going to combine our diagonal. So our next box is going to have 3x squared minus 13x plus 4. Let's set up our new box. And then we're going to multiply in a 2x. 2x times 3x squared is going to be 6x to the 3rd. 2x times negative 13x will be negative 26x squared. And 2x times 4 is going to be positive 8x. So we're going to set this equal to 6x cubed minus 26x squared plus 8x, and that's going to be equal to 24. To solve this, we need to subtract 24 to both sides and set it equal to 0. So we're left with 6x cubed minus 26x squared plus 8x minus 24 equals 0. Now we can start answering questions. Determine the possible number of roots. So this by the fundamental theorem of algebra. So say by FTA there can be at most 3 roots. Most 3 roots. Now we want to figure out what the possible roots are. So our A0, which is my P, is negative 24, and our possible factors of 24 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6 plus and minus 12. We missed plus and minus 8. So all these numbers multiply to give me 24. So plus and minus 8, plus and minus 12, and plus and minus 24. And then we have our AN, which is our leading coefficient. That's 6. So our Q is going to be plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 24. So we're being asked what the largest possible root is. So largest has to be in the form of P over Q. Our largest number in our P list is 24. Our largest and our smallest in our Q list is 1. So it's just going to be 24 over 1, which reduces to 24 as our largest possible root. Now we're going to find out what the actual roots are. So to do that, we're going to use Desmos. Let's clear out the old equation. So we'll type in 6x up to the third. Let's try to shrink this down. Minus 26x squared. Plus 8x. Minus 24. So by looking at the graph, it appears we only have one graph, which is 4.241 comma 0. So our root, we have one root at 4.241 comma 0. So let's and we can just leave it in that form as a decimal, and we are done with that example.